Imagine a world where the very act of observation changes reality. This isn't science fiction, it's the bizarre and fascinating world of quantum mechanics. One experiment in particular throws light on this strangeness, the double slit experiment. It's like a magic trick that reveals the secrets of the universe. Let's embark on a journey into this mysterious realm. The double slit experiment is a cornerstone of quantum physics. It demonstrates the wave-particle duality of matter, a concept as mind-boggling as it sounds. Essentially, this experiment shows us that tiny particles like electrons can behave like waves. But hold on, there's more to it than meets the eye. Picture this. We have a barrier with two closely spaced slits. These slits are narrow and positioned very close to each other, almost like two tiny doorways side by side. Behind the barrier is a screen that detects what passes through the slits. This screen is highly sensitive and can capture even the smallest particles that make it through. Now let's shine a beam of light at the slits. Imagine a flashlight beam, but much more focused and precise, aimed directly at these two slits. What do you expect to see on the screen? Take a moment to think about it. You'd expect two bright bands, right? Two distinct lines of light where the beam passes through the slits and hits the screen. That's what common sense tells us. It seems straightforward and logical. And indeed, that's precisely what happens when we use large objects like marbles instead of light. The marbles pass through the slits and form two distinct bands on the screen. But here's where things get really interesting. This is where the experiment takes a fascinating turn. When we use tiny particles like electrons, something truly bizarre happens. These particles are much smaller than marbles and behave very differently. Instead of two bands, we see an interference pattern on the screen, a pattern of alternating bright and dark bands. This pattern is unexpected and quite puzzling. This is a classic wave-like behavior. It suggests that the electrons are not just particles but also exhibit properties of waves. It's as if each electron somehow passes through both slits simultaneously, creating waves that interfere with each other. This dual nature of particles and waves is a fundamental concept in quantum mechanics. The interference pattern we observe with electrons suggests that they're behaving like waves, creating a pattern of light and dark bands, much like ripples on a pond. But how can particles, which we imagine as tiny balls of matter, also act like waves spread out over space? This dual nature is not something we encounter in our everyday lives. This is the heart of wave-particle duality. Electrons, and indeed all quantum particles, can exhibit properties of both waves and particles depending on how we observe them. It throws our classical understanding of particles and waves right out the window, challenging the very foundations of physics as we know it. To make things even weirder, if we try to observe which slit each electron goes through, the interference pattern disappears. This phenomenon is known as the observer effect. It's as if the electrons know they're being watched and decide to behave like well-behaved particles again, aligning themselves in a predictable manner. This is one of the most perplexing aspects of quantum mechanics. The act of observation seems to influence the outcome of the experiment. It raises profound questions about the nature of reality and our role as observers in the universe. Section 4. Unraveling the implications. The double slit experiment has profound implications for our understanding of the universe. It tells us that the world at the quantum level is inherently probabilistic. We can't know for sure where an electron will be or which path it will take. We can only talk about the probability of finding it in a particular place. Moreover, the experiment challenges our very notion of reality. It suggests that reality is not fixed and absolute but is shaped by the act of observation. This has led to various interpretations of quantum mechanics, each more bizarre than the last. Section 5. The future of quantum mysteries. As we delve deeper into the quantum realm, we find ourselves on the brink of discoveries that could redefine our understanding of reality itself. Scientists and thinkers like Thomas Young, who first conducted the double slit experiment with light, have laid the foundational stones of quantum mechanics. And Richard Feynman, who famously explained it in simple terms, brought these complex ideas to the masses, making them accessible and intriguing. Their pioneering work has paved the way for our current understanding of quantum mechanics, opening doors to new realms of scientific inquiry. Their work has opened up a Pandora's box of mysteries that continue to intrigue and baffle us, challenging our perceptions and pushing the boundaries of what we know. The double slit experiment is a testament to the weirdness and wonder of the quantum world. illustrating the strange behavior of particles at the quantum level. It's a constant reminder that our universe is full of surprises, and that the quantum realm holds secrets that are yet to be uncovered. The more we learn, the more we realize how much we don't know, and this humbling realization drives us to explore further. The quest to unravel these mysteries continues, with scientists and researchers working tirelessly to decode the quantum enigma. Promising a future filled with even more extraordinary discoveries, the journey into the quantum world is just beginning, and who knows what wonders await us.